Hi, everybody. It's Ms. McClellan. Welcome to IM2. Today we're learning 5.1.3. We have two learning goals. First, my first learning goal is that I will be able to sketch the graph of a quadratic function when given its equation in standard form by solving for its x and y intercepts and vertex. And my second learning goal is what's going to make the first learning goal possible. I will be able to use pardon me, something just popped up on my computer. I will be able to use the zero product property to find x-intercepts. Period. Okay, part A of our first problem. Our first problem is problem 526. If you're using the book, it's on page 269. And it goes like this. How many points do you need in order to sketch a parabola? Do we need 1, 10, 50? That's what we're going to keep in mind as we answer these questions. Okay, first we're going to see if all we need is the y-intercept. Let's do a little investigation. For example, let's take the y-intercept, 0, -15. Here's that-ish. Okay, I can draw a parabola through there. Is that enough? It's enough if that's the only possible parabola. But as you can see, there's more than one possible parabola that would go through that y-intercept. So this is not enough information to sketch the graph of a particular parabola. I can't decide which parabola it would need to be. And usually we're just trying to graph one particular thing. Part B says, what if I know the x-intercepts? For example, what if the x-intercepts are -30 and 50? Pardon me, there was a typo in here. If you're doing this on paper, I've probably already fixed the typo. Okay, let's look at this. What if I have -30 and 50? Well, here's one that could go through there. But you know what? There's many possible parabolas that could go through those points. They could be wider, more narrow. They could open up or down. This is not enough information. We still need to know how narrow, wide, if it opens up or down, etc. You might be wondering why we're asking these questions, and it's because in previous lessons we've been doing tables solving for so many points, and we're trying to get so that we only need a few points, and we need to know which of those points we need. Okay, well, part C says, can we sketch a parabola with two intercepts and the y-intercept? To test this idea, let's check. Let's say I have a y-intercept at 0, 15. Okay, look, I've got a little handy graph. An x-intercept at -30, it's about right here, and 50, which is about right here. Now, careful, I don't want to treat this like it's the vertex because I can tell it's not in the middle of my graph. So I'm going to go there, but I'm going to keep going up a little bit because I need symmetry. And the vertex would have to be in the middle. But because I need symmetry, this does fix how narrow or wide my parabola would be. This I think is enough information. Yeah, this is enough. Yes. This is enough to do it. Even though I don't know where the vertex is yet. So I'm going to label my important parts because anytime I graph a parabola, I want to do that. But I'm leaving question marks for my vertex. Y-intercept is at 0, 15. I'm labeling all of my important points, -3, 0, and 5, 0. And my line of symmetry is at x equals, I'm not sure because I don't know where the vertex is. Oh, actually, no, I could do this. What's between -3 and 5? -3 plus 5 divided by 2. It's 2 over 2. X is 1. So the x part of my vertex is 1. I just don't know what the y part is because I don't have an equation, so I can't solve for it. Still, this is a particular parabola. Cool. Does that mean I need 3 points? Maybe. This is my first guess. I think we need 3 points. Let's see if we can confirm or deny that as we continue with the lesson. Problem 5-27. In the previous problem, we learned that if we know the intercepts of a parabola, then we can sketch its graph without making a table. But how can we determine the intercepts of a parabola from its equation? Let's think. Part A says, what is true about the value of y for all x-intercepts? Okay, so if I'm doing an x-intercept, what is true about the value of y? Well, if I'm doing an x-intercept, I'm on the x-axis. For these two, y was 0. I think it's that y is always 0 for all x-intercepts. Okay, well, what about the value of x for all y-intercepts? Okay, well, if I'm a y-intercept, I'm on the y-axis, meaning x is 0. So 0, comma, something. For y-intercepts, x is always 0. Okay. How are we going to use that information? What's the y-intercept of this graph? Well, from our practice with tables, we know that if we know our x value, and we do because it's a y-intercept, so x equals 0. When we have our x value, we can plug it in and solve for y. So plug in 0 for x. Y equals 2 times 0 squared plus 5 times 0 minus 12. Y equals -12. Because anything times 0 is 0. So these pieces go to 0. Okay, then the y-intercept is 0, comma, -12. No big deal. What equation would we need to solve for the x-intercepts of this graph? So this question is trying to, this is part C, you can't see because there's a whole bunch. This question is trying to get us to do what we've done before again, except now instead of plugging in 0 for x, we're going to plug in 0 for y, because when we have x-intercepts, y equals 0. So we have 0 equals 2x squared plus 5x minus 12. And that's just it. I'm not even trying to solve it yet. That'll be on the next page. I want the y, I want the x-intercept. I know y is 0. I'm going to solve that equation. We actually are going to use a new technique that we haven't done before in our math careers to solve it. Next page. Okay, so the equation that we just wrote down is written in the next part. Here it is. the solutions to the equation, 2x squared plus 5x minus 12 equals 0, called zeros of the function y equals 2x squared plus 5x minus 12. At this point, can we algebraically solve it? And the truth is no. We have two unknowns, x squared and 5x, in one equation. And we can't solve one equation with two unknowns, except there's something really special that works here. It's called the zero product property. It's exciting. How often do you learn a brand new technique for solving problems? Like basically never. Up until now, it's been multiplication, division, addition, and subtraction, but this is going to be new. First, we're going to factor this. So we're going to rewrite this equation in factored form. Okay, back to factoring days. My x squared term, I'm going to write it right here, 2x squared. 1's term is going to go here. I know that the product of the diagonals of my area model will always multiply to the same thing, meaning this diagonal multiplies to negative 24x squared. So this diagonal must also multiply to negative 24x squared. Trying to solve for these missing boxes. I also know that those boxes will add to 5x. So I need to figure out what multiplies to negative 24x squared and adds to 5x. I'm going to look at my factor chart because that's the easiest way for me to do it. So we've got negative 24. I know I need a positive and a negative. I know I need the bigger number to be positive so that I add up to a positive number. So could it be negative 1 times 24? I mean, no, couldn't. So let's keep listing. Negative 2 times 12. Negative 3 times 8. Yeah, that's it. Because 8 minus 3 is 5. Negative 3x, 8x. Now I'm going to factor it by finishing the box. Okay, greatest common factor of the top row is x. And I can use that to solve the rest. Factored form, 2x minus 3 and x plus 4. There we go. Did it. Feeling a little proud. Let's continue. Part B. Now that the equation is written in factored form, you can use the zero product property to solve it. Use one factor at a time to determine what x value makes it 0. At this point, I'm going to turn to the next page, take a little pause, and explain the zero product property, okay? So here's a graphic organizer for that. So there's this thing, it's called the zero product property. It's amazing, and I'm very excited. It turns out that when the product of two or more factors is 0, one of those factors has to be 0. And it's known as the zero product property, which is that if a times b equals 0, then a equals 0 or b equals 0 or both. So I'm just going to do a couple of examples right here on the side. For example, 5 times 0 equals 0. True. 5 times x equals 0. That tells us that x is 0. 5 times x plus 1 equals 0. Well, that tells us that this thing, x plus 1, must be 0. So x is negative 1. There's a lot of practice you can do on this online. In particular, I like Khan Academy. But let's finish this graphic organizer. So, for example, if 2x minus 3 times x plus 5 is 0, then either 2x minus 3 or x plus 5 should equal 0. If 2x minus 3 equals 0, then I can solve for x. Plus 3 to both sides. 2x equals 3. Divide both sides by 2. Get to x equals 3 over 2. So one of the possible answers is 3 over 2. If x plus 5 equals 0, subtract 5 from both sides, and you get x equals negative 5. Or x equals negative 5. Okay. So I'm just going to, having defined that, go back to the original page. Here it is. Okay, part B. Now that the equation is written in factored form, we can use a zero product property. Use one factor at a time to determine what x value makes it equal to 0. So we have 2x minus 3 and x plus 4 both needing to be set equal to 0. We just did it in our definition, but I'm going to do it again right here. So 2x minus 3 equals 0, or x plus 4 equals 0. And let's solve both of those. Plus 3, 2x equals 3, divide both sides by 2, gets me x equals 3 over 2. Subtract 4 from both sides, gets me x equals negative 4. What we've done here is we found what x values make this equation equal to 0. That means we found our y and our x-intercepts. Our x-intercepts are 3 halves, comma 0, and negative 4, comma 0. The last thing we need to find our x-intercept, to complete our parabola, is the vertex. And our textbook will have us add our x-intercepts together, divide by 2, find the middle. But I'm going to show you a little formula because it's quick and easy. And it is that negative b over 2a equals the x coordinate of our vertex. B and a come from our equation of a quadratic written in standard form, which is ax squared plus bx plus c. Here we have b equals 5 and a equals 2. Therefore, negative b over 2a equals negative 5 over 2 times 2, which is 5 over 4. We can use this by plugging it into our original equation to find the y coordinate of our vertex. So our vertex is going to be, let's solve for y. Y is going to be equal to 2 times 5 over 4 quantity squared plus 5 times 5 over 4 minus 12. You plug that into your calculator and you make no mistakes. What do you get? Pardon me, I need a calculator. Okay. So 2 times 5 over 4 squared plus 5 times 5 over 4 minus 12 equals negative 2.625. Telling me that my vertex is at, what's 5 over 4? I want them both in decimal form. 1.25, comma, negative 2.625. Oh, students, I'm so sorry. I made a mistake. This should have been negative 5 over 4. I'm highlighting my error so that you can make corrections on your paper. That's going to change my x value to negative 1.25. and it will change my y value as well. So let me go up and correct that. Making those into -5/4. -15.125, that's very different. Sorry about that. Okay. Now we have our vertex, our intercepts. Let's sketch our graph. Okay. So we need to go down to -15.125, comma -1.25. It's about here-ish. I have an x-intercept at -4. It's about here-ish, and 3/2, which is about here. My y-intercept is at -12. So I'll be 2, 4, 6, 8, 10, 12, about here. Okay. Smooth curve. Label your important points. Okay. So my line of symmetry is that x equals -1.25. One of my x-intercepts is at 3/2, 0. Another x-intercept is at -4, 0. Y-intercept is at -0, -12. Vertex is -1.25, -15.125. Okay, looks like we have enough time to finish this one. Use the zero product property to determine the x-intercepts of the parabola y equals x² plus 4x minus 5. So this is what we're going to do. We're going to set it equal to 0 because I want y to be 0. That's step 1. Step 2 will be factor. I have my x² minus 5. Need to multiply to -5x². Need to add to 4x. That's going to be 5x times -1x. I find the outside of my box. Step 3. Write in factored form. And solve for x. So this is going to be x minus 1 equals 0, means x equals 1. This is going to be x plus 5 equals 0, gives me x equals -5. And my x-intercept, step 4, conclude that we have 1, 0, and -5, 0 as my x-intercepts. 4 steps, not that bad. We're going to use we're not going to use our x-intercepts to determine the vertex of the parabola, but you could. Just find the middle and plug it in. Let's do it actually. Okay, 2, 4, 6, 8, 10. So here's -5, 0. Here's 1, 0. I know the vertex will be between those. So if I had -5, -4, -3, -2, -1, 0, 1, and I want to go between those. I know that my line of symmetry will be at x equals -2, which means I can plug in -2 to my equation. Y equals -2 squared plus 4 times -2 minus 5. This becomes 4 minus 8 minus 5, which becomes -4 minus 5, which is -9. So my vertex is at -2, -9. -2, -9. Sketch the graph. Okay, I also want to do my y-intercept when I sketch my graph, but that's really fast because if I set x equal to 0, then these two terms kind of disappear. It becomes y equals 0 plus 0 minus 5, which is -5. Y-intercept is at 0, -5. It's right about here. Okay, graph it. Label the important parts. Golden. Done. So how many points do you need? You need 3 in order to figure out how wide your parabola is going to be. Yeah, this has been great. Thanks for your time, everybody. You need to practice factoring and finding x-intercepts, but this will keep happening, so don't think this is the last time you're going to see it. There will be more support. This lesson is not a one-off. Have a great day. Bye.